All right, so we're looking at solving equations using completing the square. So the completing the square, we want to add half of our b value squared. So in this first step, we want to get rid of this 11. So we're going to add 11 to both sides of our equation, getting rid of it on the left, which gives us x squared minus 6x equals 27. Our next step is going to be adding half of our b value squared. So our b value is -6. So -6 over 2 squared gives us -3 squared, which is 9. So we're going to add 9 to the left, and because we added to the left, we have to add 9 to the right to keep the equation equal or balanced. And so on the left, we can now use the completing the square to factor this. This is the perfect square, and so that gives us x. X squared becomes x, and the -6 take half of that, and we get -3 squared equals. And on the right hand side, we're going to get 36. Now, typically this is where we would move the -36 to the 36 to the left hand side and set it equal to y for a vertex form of our equation. But since we're trying to solve, we're going to take the square root of both sides, getting rid of the square, and that gives us x minus 3 equals plus or minus 6. Anytime you take the square root of both sides of an equation, you have to use a plus or minus, because the square root of 36 is asking us what number times itself is 36. Well, 6 times 6 is 36, and -6 times -6 is also 36. And so our next step is to get x by itself by adding 3 to both sides. And so that gives us x equals 3 plus or minus 6. And so basically you have two problems to solve here. So you have x equals 3 plus 6 and x equals 3 minus 6. And so you end up with a solution of 9 and -3. And so those are our two solutions, 9 and -3. You can always go back and plug those answers into your equation to verify the solution. Let's go ahead and check one of those right now. So if we take 9 and plug it into our equation, 9 squared minus 6 times 9 minus 11 equals 16. And so 9 squared is 81. 9 times 6 is 54. Minus 11 equals 16. And so 81 and -54 is 27. Minus 11 equals 16, and 27 minus 11 is 16. So we get 16 equals 16, which we know is correct. We can also do it with the -3. And so -3 squared minus 6 times -3 minus 11 equals 16. -3 squared is a positive 9. -6 times -3 is a positive 18. Minus 11 equals 16. And the 9 and 18 gives us 27. Minus 11 equals 16, and that gives us 16 equals 16, which is again correct. And so we know that when x equals 9 and when x equals -3, the left-hand side of our equation will be equal to 16. I'm not going to do that on every problem, but that is a great way to check your solutions. All right, so let's look at our next example. Again, we want to get this to where we have our a and b term by themselves. If you don't remember what I'm talking about, our standard form of a quadratic is ax squared plus bx plus c. And so here is my a and here is my b. I want to get them by themselves. This is the c. And so again, we're going to subtract 10 from both sides of the equation, giving us -2x squared plus 20x equals a positive 10. Now, before we can do the completing the square portion of this, we do need to factor out what is in front of x squared. So we need to take a -2 out. Basically, that's going to have us dividing these two terms by -2. And so what we get is a -2 outside a set of parentheses, and -2 divided by -2 is a positive x squared, and 20 divided by -2 is a negative 10x. All right, so I'll always leave my space. And again, if you watched one of the previous videos, I talked about the new b and the old b. And so this here would be my old b. And this is my new b. And as I talked previously in the one of the last videos, we want to use our new b instead of the old b. And so we take half of negative 10. So negative 10 over 2 squared gives us negative 5 squared, which is a positive 25. And so we're going to add 25 to the left. Now, on the previous problem, in the previous video, we talked about if you add something in the parentheses, you have to take account what is in front of the parentheses. So in front of the parentheses is negative 2. So to continue to make this equation balanced, we need to add negative 50 to the right-hand side, because negative 2 times 25 is negative 50. So we're going to add negative 50 to the right-hand side. All right, let me move this out of the way. All right, so the negative 2 drops down because we're ready to write this as a perfect square. So drop your negative 2 down. The x squared becomes x. Half of the b term from the previous step is negative 5 squared. So x minus 5 squared equals, and on the right hand side we get a negative 40. All right, so now we want to get the last problem. I was able to go ahead and square root both sides because all we had was a parentheses squared. But now we have a negative 2 in front of the parentheses, and to solve an equation you have to get rid of multiplication before you can get rid of exponents. So we're going to divide both sides by negative 2. And that gives us x minus 5 squared equals 20. And so then our next step is to get rid of the exponent of 2 by square rooting both sides. And so that gives us x minus 5 equals plus or minus the square root of 20. Since we don't know the square root of 20 off the top of our heads, we'll just leave it as plus or minus the square root of 20. To get x by itself, we'll add 5 to both sides. And so what we end up with is x equals 5 plus or minus the square root of 20. So in your calculator, you're going to do 5 plus the square root of 20, and that will get you a 9.47. And then you're going to do 5 minus the square root of 20, which gets us 0.527, which would round up to 0.53. All right, either one of those is fine. All right, so what happens if the completing the square has already occurred and you're given a problem such as here in example 3? And I could have noted this prior to this, but order of operations which many of you may know is Please Excuse My Dear Aunt Sally, or PEMDAS, okay, PEMDAS has us evaluating, okay, going forward. So if you're given a problem and you're substituting an x, or substituting a number in for an x, that would be evaluating. And so if you're evaluating, you use PEMDAS in the forward motion way, the direction. So you'd start with your parentheses, then your exponents, your multiplication, division, your addition, subtraction. But if you're solving, okay, we want to do order of operations in the reverse order. So we want to look for subtraction, addition, then we want to look for multiplication, division to get rid of, then exponents, and then parentheses. Let me just highlight this real quick. A lot of people think addition and subtraction go in a specific order. Really, addition and subtraction are equivalent to each other. just as multiplication and division are equivalent to each other, exponents and parentheses are not equivalent, so they go in a different order. Parentheses is its own, and it goes last when you're trying to solve. All right, so let's use that idea to help us solve this. So the first thing I want to look for is addition, subtraction. Is there any addition, subtraction I can get rid of? And just to note, you can't do anything in the parentheses because parentheses would come last. So even though I see a -5, we can't do anything with it. So I'm going to start off by subtracting 10 from both sides to get rid of the addition. And so that gives us a negative x minus 5 squared equals 16. My next step is to look for any multiplication division I can get rid of. Just a hint in this problem, it will be located in front of the parentheses, and there we see a negative, which is assumed to be a -1. So we're going to divide by a -1 on both sides, and that gives us x minus 5 squared equals a negative 16. And then from here, we can try to get rid of the exponent. To get rid of an exponent of 2, we want to square root both sides. In doing so, we get x minus 5 equals plus or minus the square root of negative 16. Well, until you've studied imaginary numbers, you can't take the square root of a negative. And so this tells us that because you're taking the square root of a negative, that there's no solution. And we're done. All right, so just make sure anytime that you're taking the square root of a negative, you know to write no solution. All right, example 4. Example 4, again, we want to use this idea of our PEMDAS. So let me just go ahead and bring that illustration down for us so that we can continue looking at it as we're trying to solve this. Okay, and so again, the first thing I want to look for is addition, subtraction that we can get rid of. I see we have a +2, and so we'll subtract 2 from both sides to get rid of the addition on the left. And so we have 2 times x plus 5 squared equals 72. Our next step is going to be looking for multiplication division. I see we have multiplication, the 2 in front of the parentheses, so we're going to divide by 2 on both sides. And that gives us x plus 5 squared equals 36. Then we'll look for exponents to get rid of. So we see the squared, so we square root both sides. Parentheses will drop once the squared's gone, so x plus 5 equals plus or minus 6. All right, so then we're going to subtract 5 to get x by itself, and we get x equals -5 plus 6 and -5 minus 6. And so our solutions here are x equals +1 and x equals a -11. And you can quickly check those answers. If we come back up here to the top, I know I didn't do it on the second problem in this set. I'm sorry, the first problem. But if we come back up here to the top, just a quick test. You plug a 1 or a -11 in. So 2 times 1 plus 5 squared minus 2. We want to ensure that this equals 70. And so we get 2 times 6 squared minus 2 equals 70. 2 times, or 6 squared is 36. Times 2 is 72. 72 minus 2 is 70, so 70 equals 70. And we can test that again with the 11, or the -11. So 2 times -11 plus 5 squared minus 2 equals 70. So we get 2 times -6 squared minus 2 equals 70. -6 squared is 36. So 2 times 36 is 72. We get our 72 minus 2 again, So 70 equals 70. Again, you don't have to check your answers, but it's just a good habit to get in, and it also helps to build confidence in what you're doing and knowing your solutions are correct. All right, guys, I hope this video helped. Have a good day.